Welcome to the e-learning course for Asprova hands-on training. Section 2. Creating a prototype and investigating systemization. Let's take a look at the item structure. A is a bolt. B, C and D are similar kinds of bolts. X is a cap. It is a common item used with bolts A, B, C and D. X2 is also a cap. It is an alternative item to X. By assembling one unit of A and X, we produce AX, a bolt. By packing AX into 100 units and 200 units, we can produce AX100 and AX200. BX100, BX200, CX100 and CX200 have the same structure as AX100 and AX200. Let's look at the process chart. Items A, B and C go through three processes: cutting, processing and inspection 1. Item X goes through two processes: assembly and inspection 2. Items AX, BX, CX go through two processes: assembly and inspection 3. Items AX100, AX200, BX100, BX200, CX100 and CX200 go through one process: packing. 2A. Creating master data. Let's enter the master data using the integrated master editor. Starting Asprova. Click on the Start button to display the Windows Start menu. Select the following: Programs, Asprova APS, Asprova, from the menu to start Asprova. Let's select the module type by selecting Module from the menu bar. Next, select Change Module Type. Select MS and click the OK button. Let's create a new project by selecting File from the menu bar. Next, select New. When the initial settings dialog is displayed, set Workspace Mode to Standard Mode and click the OK button. First of all, let's enter the data only for manufactured part A. Let's take a look at the process flowchart for manufactured part A. In order to make manufactured part A, the raw material M1 goes through three processes: the cutting process, the processing process, and inspection 1 process. The machines required to produce manufactured part A and their capacities are as shown. Based on this information, let's enter the data into the integrated master editor. Open the integrated master editor table by selecting Table View from the menu bar. Select Integrated Master Editor. Click the Maximize button to expand the window. The Integrated Master Editor table. Just like Excel, we can close up the columns for that information that we don't need. In the Item field, we enter the name of the item, A. Enter the process number 10. Enter the process number in ascending order according to the order of the processes. Enter the smallest value in the first process and the biggest value in the last process. Enter the process code CT. Note that you cannot enter duplicate process codes when you produce the same item. Set the instruction type to Input Instruction. An input instruction is an instruction regarding the item that is input to the process. For the input instruction, the resource item field represents the item that is input to the process. Enter the raw material M1. Enter 1 for the production. This specifies the quantity of the input item required for producing 1 unit of the output item. After we have finished inputting an instruction, we enter the next instruction on the next line. Enter A for the item. Enter 10 for the process number. Enter CT for the process code. In the instruction type field, select the use instruction. In a use instruction, you can specify resources to produce the item, such as equipment or operators. The instruction code is automatically set to M. M represents a main resource. The main resource means equipment or operators that produce the item. In the resource item field of the use instruction, enter the resource that is used in the process. A resource refers to any equipment, operator, metal mold, tooling, and so on that are required to produce an item. Set the resource to CT1. Setup represents the time required for the setup. Enter 10 for 10 minutes. Enter 20 for the time required for the teardown. Production represents the capacity of the resource. Enter a capacity value and a capacity unit for the production. In this case, the capacity is 5 MP, which represents 5 minutes per piece. Now that we've finished the first process for cutting, let's set up the second process, processing. Once again, we set the item to A. For the second process, set the process number to 20. Set the process code for the processing process to PR. For the instruction type, select Use Instruction. Set the resource field to PR1. Set the setup for PR1 to 30 minutes. Set the production capacity to 8 MP. The time constraint method specifies the relationship between the current process and the previous process. By clicking the button in the time constraint method cell, you can bring up a pull-down menu listing the various time constraint methods available. There are 7 types of time constraint method available, each specifying the time relationship between the current process and the previous process. Types of the time constraint method include ES, end start, SS, start start, SSEE, start start end end, EES, end each start, and ESE, end start each. For the current process, we will select ES to define the minimum amount of time separating the end of the previous process and the start of the current process. Set the time constraint method to ES, end start. This means that the previous process must end before the current process can start. The time constraint min specifies the minimum time value required to be left between the processes. Here, the processing process can start 60 minutes after the cutting process has finished. Set the time constraint min to 60 minutes. Let's set the data for the final process, inspection 1. Set the item to A. Set the process number to 30. Set the process code for inspection 1 process to CK. Select Use instruction. Set the resource to CK1. Set the production to 1 MP. Set the time constraint method to ES. Set the time constraint min to 60 minutes. We've now finished entering all of the data for manufactured part A into the integrated master editor table. Next, let's specify a shift using the shift table. Open the shift table screen by selecting Table View. Next, select Shift. The shift table. The shift table specifies patterns of available time that can be assigned to resources and days in the calendar. In the shift code field, we specify a name for the working pattern, S1. In the Patterns field, we specify time periods separated with semicolons. Here, we will specify a pattern for the time period from 8 o'clock to 6 o'clock, with an hour lunch break from 12 o'clock to 1 o'clock. We've now finished entering all of the data for the shift table. Next, let's specify the calendar information. Open the calendar table screen by selecting Table View. Select Calendar. The calendar table. The calendar table specifies shifts for each resource and day. The resource field specifies the codes of the resources to whom this calendar record will apply. An asterisk means that this calendar record will apply to all resources. The date or day of the week field specifies the date to which this calendar record will apply. You can not only specify dates directly, but also by days of the week or a range between dates or days of the week. An asterisk means that this calendar record will apply to every day. The shift codes field specifies the shift codes to be applied to the specified resource codes and dates. Set the shift code to S1. Now, let's specify the order information. Select the order table by selecting Table View, and then select Order. The order table. The order table specifies the orders, each of which corresponds to an actual unit of production that will appear in the schedule. The order code is used to identify each order. Each order code must be unique. You can use a character string as well as alphanumeric characters to specify the code. Set the order code to 10. The item field specifies the item to be produced. set the item to A. The LET, latest end time field, specifies the time by which production must be completed. Set the LET to 2003 October 31st. The order quantity field specifies the quantity to be produced. Set the order quantity to 100. The priority field specifies not only the priority of the orders, but also the direction of the assignment. The priority is a number greater than 0 and less than 100. Depending on the priority, the assignment is different. A priority greater than or equal to 90 or less than 100 is assigned forward. A priority greater than or equal to 50 and less than 90 is assigned backward. A priority greater than 0 and less than 50 is assigned forward. Set the priority to 95. Now that we have registered all the data necessary, let's change to the Resource Gantt chart by clicking on the Resource Gantt chart tab. Let's specify display colors and display orders according to the process flow, so that resources can be easily checked on the Resource Gantt chart. Move the mouse to the slider between the resources and the Gantt chart. Click the slider and drag to the right to reveal the resource table. Scroll to the right to find the display color and display order fields. Set the display colors and display orders as shown. Drag the slider back to its original position. Next, we will specify the scheduling basis time. The scheduling basis time means the time and period for creating schedules, such as assignment start time and assignment period, as well as the basic time to determine the range and period in displaying charts such as display start time. Select Schedule Project Settings from the menu. Select the Time Periods tab. Select Scheduling Basis Time. Click the Clear button to remove the current setting. Select the text box. Let's specify the scheduling basis time as 2003 October 1st. In the same way, let's now specify the display start time. The display start time means the time from which the chart starts to be displayed. Here, we will specify the past display period as 2 days. By rescheduling, you can perform high-speed automatic scheduling based on the master data and the orders entered in Asprova's integrated master and order table, and display the resulting schedule on the Resource Gantt chart. Select Schedule, Reschedule from the menu. Each bar represents an operation. Since there are 3 processes set in the integrated master, 3 operations are generated. Currently, we have only specified the main resource for each process. Now, let's specify sub-resources for each process as well. Let's return to the integrated master editor table. After rescheduling, the input instructions we didn't enter have been automatically added. Press the F3 key to redraw the screen. In the instruction code, M represents a main resource. The main resource means equipment or operators that produce the item. S0 to S9 represent sub-resources. The sub-resources could be metal molds, tooling, operators, and so on that are attached to the main resource. You should always specify at least one use instruction of type M. You can specify type S use instructions as necessary. You can also specify an arbitrary code as well. Let's specify the sub-resource for the CK process. The sub-resource is a checker, CKR. Click the left mouse button to bring up the pop-up menu in the line in which you want to make the insertion, and then select Insert. Next, select the Use instruction. Specify S0 for the instruction code. Specify CKR for the resource. As CKR is used for production, enter in the production column the same value as CK1. If you enter 0, it will have the same meaning as the value corresponding to the resource capacity of the main resource. Let's specify the display color and display order in the resource table for the new resource CKR. The resource table. Set the display color and the display order. Return to the resource Gantt chart. Select Schedule, Reschedule from the menu. You can see that the resource CKR has the bar assigned for the same time as the resource CK1. For a single operation, a project has been proposed to use 2 resources, namely CK1 main resource and CKR sub-resource. Next, let's specify the sub-resource for the PR process as an internal setup resource. Once again, click the left mouse button on the line in which you want to make the insertion and select Insert Use instruction. Specify S0 for the instruction code. The sub-resource is a process inspector. Specify PRIN for the resource. As PRIN is used for setup, enter in the setup column the value 0. The internal setup resource PRIN will do the internal setup operation for the main resource PR1. Enter the display color and display order in the resource table for the resource PRIN. Return to the resource Gantt chart. Let's reschedule again. You can see that the resource PRIN has a bar assigned for the same time as the setups generated for the resource PR1, and a schedule has been created to operate the respective setups. Finally, specify the sub-resource for the CT process as an external setup resource. Select Insert Use instruction from the pop-up menu in the line you wish to make the insertion. Specify S0 for the instruction code. Specify CTS for the resource. As CTS is used for setup and teardown, the setup time and teardown time specified for the resource CT1 are moved to CTS. The internal setup resource CTS will do the external setup operation for the main resource CT1. Enter the display color and display order in the resource table for the resource CTS. Return to the resource Gantt chart. Let's reschedule. You can now see that the resource CTS has the bars assigned for the setups and teardowns generated, instead of resource CT1. This is the end of Asprova hands-on training, Part 2A. Thank you for watching.